In this presentation, the fitness for service assessment module of Kratos Power Inspection Solution is going to be presented. From their RBI module, we have realized that once a report is approved, then the user is capable of doing fitness for service assessment upon their wish. So here we have an approved report that fitness for service assessment window is open, but this is an ongoing or in progress report, and we don't have any similar window. Here we can see different damage mechanisms that are covered in this assessment. We start with general metal loss. So we have the equipment, pressure vessel, we have component. We may select which component we are going to consider in the assessment. This equipment has already two components, so both of them are presented. The test point I'm not going to select because I'm going to insert the data manually to be sure that all the data are correct. Here we have design code. This is previously selected or inherited somehow. It's inherited. The design, pressure, and temperature are inherited. The flow location, which type of shell, it's cylindrical shell, but also other types of shell are covered here. Flow is located away from discontinuity or on a nozzle. So there are supplement loads for force. We may select this one, and in the load section we have to include the details of loads, external loads of course. So I detect this one. Discontinuity to the nearest structural discontinuity, distance to the nearest structural discontinuity, let's suppose it's 130 millimeters. Now we don't have any error message. Material specification for a shell is, let's suppose it's this one. Yes. And you can see that the material is selected and the allowable tensile stress is present. Dimension is another crucial data, is arguably the most one that we have to include. So nominal thickness as fabricated is this one. Let's suppose the inside diameter is 3000 millimeters. Well joint efficiency is, let's suppose it's 1. Uniform metal loss inside is 12. Outside is 1 maybe. Future corrosion allowance inside, it's, let's suppose it's 5. The future corrosion allowance is a factor of the estimated corrosion rate and the interval that we are going to consider for this assessment. Outside, let's suppose it 3. Oh, future corrosion allowance 50 is very high, so let's suppose it's 10. And well, here in the type of thickness data we have 3 options, and each of which is going to be fully explained. First, let's start with minimum thickness. So the minimum measured thickness, let's suppose it's 132, for example. Loads, I have already explained the load, and results, let's do a run. It's the simplest approach, and it consider the data here. It present the data here. In the second tab, you can see the results of the assessment. It satisfies a level 1 assessment and it satisfies level 2 assessment. Then in the third tab, you may see step-by-step results to realize which kind of calculations are included in this assessment. Now let's change the type of thickness data to a random thickness location. Well, the values have to be inserted. The second one is 132, 149, I don't know, 1 140, 129, 133, 140. So again, let's do a run and see. This is a step calculation again, and the result again, it satisfies the level 1 assessment as well as level 2 assessment. Now if I change these values a little bit, so let's suppose it's 100 and 98, 99. Let's see what will happen. Well, again, it satisfies. Why? Here the dimension. So let's increase the future corrosion allowance to 30 millimeters. Let's suppose it's a quite harsh environment. So here you can see that the level 1 is not satisfied because the permissible maximum allowable working pressure is greater than design pressure. However, the level 2 is satisfied. And here again, here we can see coefficient of variation, then different things that are calculated by software. The last type of data entry is rectangular thickness grid, where once we have some exact inspection plans, then we may use rectangular thickness grid. So here are the number of actual profiles and number of circumferential profiles. Uniform grid spacing is selected but may not be selected. Here is actual spacing. Let's suppose it's 30 and let's suppose it's 25. Of course, there are some calculations for the distances between different inspection plans in API 5, 7, and 9. So here I select these two values, and then I'm going to insert the recorded thicknesses. So the recorded thicknesses is, let's suppose this is like this value, or this value, this value, and this value. Now the data is inserted, and now let's do a run. This is the input data. This is the result summary. Again, it does not satisfy level 1 and level 2 assessment, and here is the step-by-step calculation results. So we already have done a fitness for service assessment for general metal inspections, general metal loss. So let's look at other modules. Well, we have local metal loss, we have fitting assessment here. Again, the pertinent data has to be inserted. Quite similar. So again, distance to the nearest discontinuity is this value, let's suppose. The rest of the menu is quite the same. Material, we have to select material, and grade. So now we have to insert. We have already inserted these values. So dimension, nominal thickness as fabricated is 150. Inside diameter is 3000, and here this is not essential. We have also the opportunity to insert the minimum required thicknesses, both longitudinal and circumferential, manually, or whether we may ask the software to calculate them. This is also the case for all of the damage mechanisms in which minimum required thickness is required. Distance from discontinuity is already inserted. Uniform metal loss, let's suppose it's 12 millimeters. Outside 2 millimeters. Future corrosion allowance is let's suppose 5 millimeter, and outside is 2. Having inserted the above data, now we have to determine about or decide about the pattern of pitting. So the pattern of pitting also is important or crucial in type 1 pitting analysis. Here we have type 1 with pit graph or pit charts, and level 2 with pit pair data. So for the level 1, here we have different pitting charts or grades. The picture is presented here, and the inspector or the engineer has to determine or select the pattern with the nearest similarity or most similar to the actual damage that he or she observed. So let's suppose it's my observation is this one, and the maximum pitting depth is 30 millimeters. And now we come here and we do a result analysis, and here we can see that satisfy this pitting pattern, or this type of pattern satisfies level 1 as well as level 2. And we have also the option to use a more sophisticated level which deals with pit pair data. It's quite sophisticated. It requires an exact dimensions regarding the observed damage, about the pitting orientation towards each other, the pitting millimeter, etc., etc. Well, we had an overview to the capabilities provided in Kratos Power Inspection Solution software in terms of fitness for service assessment. Of course, everybody knows that fitness for service calculations are quite sophisticated and require mainly a high level of engineering knowledge, corrosion knowledge, mechanical engineering knowledge, material engineering knowledge, and so and so. However, as you saw, the procedures are very simplified in the software, so as a user can easily do level 1 and level 2 assessment for most of damage mechanisms, of course, except for cracking, which only level 1 is provided, to realize whether the pressure, whether the component or the equipment for the proposed next interval is okay or not, and if not, he or she may prefer to further the fitness for service assessment in level 3 and with subject matter experts. By having these capabilities in your asset integrity management software, you may be sure, you are very likely to be assured that you have most of the required equipment and facilities in terms of software facilities to decide very effectively which of the equipment should be out of service for further repair, and which may sustainably do their performance in the plant. Thank you very much for your attention.